right. Hi, everyone. I am Suhaib. I come from Pakistan, which some of you might have seen in Call of Duty, which might look something like this. But that's not how my country actually looks. It more is like this. It's pretty. I really love to brag about it and so on. Anyways, less about country, more about me. I am now a CEO and game director at my own studio called TalTech Games. It's fairly new, it's small, and I'm going to be building. I've been in game development for over 10 years now. Professionally, been working with games for about 15. And in the last decade, I have released projects which is Aeon Must Die, Myth Force. If anyone wants to get connected, there's the QR code. Feel free to reach out to me with any questions. What are we talking about today? It's why, when, how, optimizing games in Unreal Engine, which is a dreadful topic for a lot of us. It can be kind of boring as well sometimes, but I have spent like half a decade working with these things, and oh boy, I can tell stories. Right, first, before we get into how, we have to talk about why we care about optimization. I think in the previous presentation already, we have been talking about things like project sizes and so on, right? But the first very important aspect is when you're releasing a game, it's the players who you care about. They can have PCs or devices somewhere ranging from potato PCs to beasts of machines, and we want to make sure to run the game on as many platforms as we can. I mean, you want more sales, you got to get your game running on as many things as you can. Target audience matters. And mainly, like us as game developers, we kind of care about our players. If you don't care about players, I think there are way better fields out there. But when it comes to games, this is kind of essential, right? You're designing experience, and optimization is part of that experience. If frames tank, if motion sickness happens through jittering and so on, all of these things are going to ruin the experience and eventually lead for players to just leave your game. Especially with Steam Refund, you might actually get a refund in under an hour, so you don't want that. There's also market perception. Unreal Engine at the moment has this a really fun thought process that goes on, which is like, oh, game made in Unreal Engine, it is going to be bad. There's a bunch of reasons for it. First of all, Epic decided to market their engine in a way where it is considered to be a very high-spec engine, and it is a high-spec engine. So a lot of features are enabled by default, which makes it, which you need to bring down. As opposing to Unity, where you need to take things upwards, you need to actually strip things down from it. And any game in Unreal Engine that comes out nowadays, these are the comments you're going to see everywhere. Really fun. So one of the fun things that happened, like why this happens, right? It's generally ends up happening because of certain bad practices. We kind of adapt, or people you work with, or they don't teach you, or they don't know themselves either. It could be anything. So I was working on a game which didn't release. So what was happening in that is that there was a single actor that would load the whole 12 gigabytes of game into memory. If you were to take an empty level and put that one asset, it would load the whole 12 gigs of game. And we wanted that to be on Nintendo Switch. Switch has only 4 gigs of RAM. So, it crashed. It was a lot of fun. I wish I could show the game itself, but I can't. And yeah, and I'm pretty sure the slide was supposed to be ahead, but it's fine. Another reason you care about is if you're going for a publisher, you want to make sure that your game is running at the correct FPS and your game is running on the devices that you're targeting, because even though the game publishers are working in games, they do not necessarily have high-end systems. They might be on the move, they might have the laptop, they are going to have lightweight laptops, and if the game doesn't run on that, they might go like, okay, hey, I think your pitch deck looks interesting, but I can't experience it, and that might like interrupt the conversation. So you don't want that either. Many reasons mainly have to do with people playing your game. When do you optimize? There are people who love optimizing everything, and there are people who don't like optimizing at all. Both are the extremes of it, and we don't want either of them. What we want to do is we want to optimize when needed, right? We have certain ideas. There is a thing called frame budget. And we want to reach to either 30 frames per second or we want to reach to 60 frames per second. The budget for 30 frames per second is 16.66 milliseconds. So that's the render time for your game thread and GPU thread that needs to happen. For 30 FPS, it is 33.33. So that's how we start the whole conversation of, oh, what do we have to do? For certain games, it also matters where you are. For games where we are really reaction heavy, fighting games, MOBAs. MOBAs a little bit less, but Celeste, like platformers where like there are high reaction speed is required, shooters. The 60 FPS is the requirement. You cannot go below 60 FPS. If you go below that, people are going to feel input lag, and they're going to be like, okay, this is not fun. This happened to the project when we were doing publishing Aeon Must Die on Switch. We were on 30 FPS, and there was about twice the input delay that was happening, so the game felt a little bit wonky. So if someone had experienced it on PC or PlayStation, they would feel like, okay, what's happening? And that's not good. There is also sometimes that the load times could be extreme. We do not want very extreme load times. Our systems are really good. Even like the low-end systems are not that bad. So we have to figure out how to do better load times. Then game package sizes, like we've talked about before, if you're in Game Jam or if you're sending things to publisher or even to even on the market, your game package size is judged. And there is a weird idea where the price of the game kind of relates to the package size of the game as well. Like Call of Duty is about 300 gigs right now, like it's a full AAA game. But if your indie game is 300 gigs, you're going to have a really fun conversations on the internet as like, what the hell is happening there? You do not want that. Finally, memory consumption. We've already talked about the switch case. This is very common, especially with Unreal Engine. And we're going to talk about a little bit why that happens and how you can avoid it as well. The screenshot I have is from Monster Hunter Wilds. For those who have played, they've probably seen that. And we have had really fun conversations about Monster Hunter Wilds being not able to run on good PCs, where people have i5 processors and 3050 or 3060 graphic cards where they're expecting it to run on DLSS, which does not work on this one. Finally, there is the target hardware. You can be aiming for consoles, PCs, even mobiles. Your target hardwares have specs, and you as a developer need to be aware of it. Maybe while you are concepting things or later on, it can be at any point, but this is a goal as well. So we optimize based on goals, and you optimize as much as it is needed and not necessarily more than them, because at some point it is not going to benefit you. So let's get into hows, and this is going to be the longest section of this whole thing, and I'm going to bore you all to death. Right. So first, three concepts. There are three locations where optimizations needs to happen. First, if your performance problems are happening on the GPU, that is what we call a GPU bound. That GPU is choking, and you need to fix something that has to do with visuals, rendering, models, and so on. Second is CPU bound. This is generally has to do with logic. How you write your code, how everything is connected, how many nested loops you have had, for example. I've seen 5 one time, that was a lot of fun. And then finally, it's the memory, the size, the connection, how much things gets loaded, how things get unloaded, and everything, right? So even if you do not remember the rest of the presentation after that, just remember these three things, and you're going to begin your investigation with those. So first thing we need to do is find out where the problem is actually happening. And there are a few interesting commands, a few interesting tools in Unreal Engine that you can utilize to immediately visualize what is happening. The first three are a few are console commands. You can do stat FPS to check your frames per second. So you know that you're running at the correct frames per second or not. Second is stat unit. This just shows you how the frame is going on. So what's the CPU time, what's the GPU time, as I mentioned earlier. There is a frame budget. If your frame budget is crossing, you're having a problem, you need to start fixing it. Draw frames is a funny one where sometimes we think that this is a GPU thing, but it's actually not. It has to do with CPU, because there's a communication time that is happening between CPU and GPU as well, and generally draw frame gets impacted by that. Then there is stat game, which shows you how your logic is working. This has to do with CPU mostly, how many ticks, what your tick time, what other elements are taking. So, and then we have the stat GPU, which showcases how the rendering is happening. Which part of the rendering is taking more time? Is it the light? Is it the modeling? Is it maybe something else? Ray tracing might be part of it. Maybe it is post-processing. So going from that, which is just numbers are not enough. Numbers just point you into a direction what the next step is going to be. So the first very interesting tool that is part of Unreal Engine now, previously it was known by something else, it was not that great, but right now it is one of the most amazing things there. It's called Unreal Insights, and it gives you a budget breakdown of a frame. This includes your engine's tick, which means when a frame passes on the engine, and it breaks it down to the events that you're calling every frame. It is a very long tree, you can go through it. It has named events, which means what functions you are actually calling and how badly you have written. So, it lets you go like, okay, I messed this up, or someone else messed that up. So it's fairly easy to use, like it is part of a package. You can set it up standalone, or you can start it up from within the Unreal Engine. On the bottom right, there is a trace. You click on it, you start the trace, and your game starts getting checked. This will check any project that is running within Unreal Engine, or if you have made the build in Unreal Engine, it will also trace that. So you can start it out, and then you can define what channels you're tracing. Some of the channels that you can trace are GPU, memory, file, load time, and default just holds the default stuff, which is part of like CPU and so on. Point is, you go deep in the tree, go through the whole game, know your game better, understand where the problem is happening, and then go and fix that. And that was mainly for CPU, and now we come to the GPU. GPU has a similar tool, which is called a GPU visualizer. This showcases you the whole scene and how rendering is happening, from rendering of the models to the light calculations, the shadow calculations. If there's lumen and so on, that's going to get calculated. On the upper side, it visually shows the budget of how everything is split, whereas on the lower side, it actually gives you the time. So you need to make sure you look at both of them and which ones are the biggest time consumption things. And generally, these are going to be your lights, your shadows, and maybe sometimes shaders, because someone decided to write the most complex, beautiful looking shader, which happens from the concept side, and later on, you need to fix it up. To use it, all you need to do is use the command Control-Shift-, and it will immediately present you with the budget breakdown that is there. And then we start finding problems from there. The third thing is for memory. Unreal Engine has a really nice function to showcase the hierarchy and what consumes your memory on disk and your RAM. This is called a size map, and you can check that per asset, and that is one of the strongest tools. This showcases you who is hard referencing every asset, and this is actually the screenshot from the project I was talking about when I was doing the size maps for it. This is when we were halfway down, like fixing it up, but not just one asset running like 12 gigs, but one asset would load other assets, and certain assets had like breakdown, so everything thankfully was not getting loaded by the mid time of it. To use size map, you just click on the asset, right click, click on the size map, and you get the size map. Or you can use the shortcut key, Control-Shift-M. And what you can receive from that is what something's memory size is on a disk and what is the memory size when you load it on to the RAM. Both of these things matter, but RAM is generally more important for you. The memory, the runtime memory is the more important part for you. Right, so what can we do as for fixes for GPU-bound problems when we have found that, right? One of the biggest issues that happen, because Unreal Engine allows you to do practically a lot of dynamic lights, people can go a bit crazy and go like, hey, I'm going to make the most beautiful scene, and I'm going to fill it with 100 dynamic lights. Now, especially with mega lights, you can actually do that. But every time an overlap of a dynamic light happens with an actor or anything in the scene, it is considered to be an extra draw call that goes through it. So if you have 5 dynamic lights overlapping to each other, it is going to increase the complexity of it. So our goal is, when we are optimizing it, we are going to try to reduce the number of dynamic lights into the scene and move most of them that are not required to be dynamic light to be stationary lights, and in many cases, static light. So we are transferring the weight of rendering, instead of being runtime, to something that is based on the memory, so we save time because frames are more important. Level of details. Most of you have probably already learned of the word called level of details. It's just the idea that the further things goes, the less we see of them. But if you do not use LODs in the scene, which is very common when you import a asset into it with 100,000 poly counts or more, when it is in space, even if you see a little bit of it, that is still considered to be a whole mesh. So we introduce LODs, so the further something goes, the lesser triangles it has. And the good thing with Unreal Engine is that you can auto-generate LODs. You don't have to have them previously. If you do not like them, you can create them in an external tool. But to get started with, when you bring your asset in, if you feel like it is going to go outside, just auto-generate your LODs and let Unreal Engine take care of stuff. It spoils you. Let it spoil you. Be happy. MIP maps, same as LODs for 3D model, MIP maps are for textures. The only rule that you need to keep in mind that your textures needs to be the power of 2. That is why every time we are done with the art side of things, we sit down, we check all of the textures, and then we have a fight of, you've been working with Unreal Engine for the last decade, and your textures are still not power of 2. Why? We don't know, but we bring it in. So you reduce the size of 3D meshes, you reduce the size of the textures on distance base, and that is already going to help you quite a lot. Because your screen is not going to be overloaded, so you don't need to do much more. The next thing is reducing mesh count. Generally, we do setups with a lot of cubes and so on. Every cube or every object in your scene is rendered separately. GPU is a beautiful thing. It can take many more objects simultaneously to render them in a single frame, whereas taking it one by one is kind of difficult for them. So we utilize ways to reduce or send single draw calls to draw multiple objects together. First one is we can merge multiple actors together into a new actor. Once you're done with your scene, it looks beautiful, and it's only there for visual purposes. We can combine all of them to create a new mesh, which allows you to basically have a singular mesh instead of 10 meshes that would originally be there. The second thing we can use is what we call instance static meshes or hierarchical instance static meshes. And there are some neat examples by Micah, which I won't open the link right now, but maybe the slides will be shared later on. You can check in. And he created a whole outer space with about, I believe, 50,000 different instances of meshes through instance static meshes. And what happens is that graphic card don't render it separately, but it takes it all as a one batch and it renders it out. And this can save you quite a lot of time. We utilize this in places where we have very many similar items. One example is if you are ever making a bullet hell, you are going to be utilizing something like either a Niagara system, a VFX or something, or you're going to be using instance static meshes. So it's kind of like when I was talking about example, I have put a list down which is like, this is a fairly big space. If these were all individual actors or individual objects, they would have not given you 60 plus FPS, but with something like instance static meshes, it enables you to do that. Next thing is material counts. When you are making your model, try to export it in a way where there is less material counts in it. So every time you're creating a material for specific things, you can actually place it all on a single material or two materials instead of separately. There are really fun techniques that are available out of that, but every material increases your processing time exponentially. So every material is a different draw call, and that is going to slow down your processing on GPU. So if you see this, you know you have a problem, you need to fixing it, you need to start reducing it. Now, fixes for CPU-bound problems. Loops, like I talked about, nested loops, really bad. If you see this, please find ways to fix them. And you probably don't need 3 nested loops or 4 nested loops. You can probably do it in one. This has to do with learning a little bit more about coding, a little bit more about architecture, but it is an interesting subject. And it's going to improve your coding as well. Then we need to limit the usage of what we call get all actors of class. This is kind of a queuing system which allows you to test all the actors in the class and give you what you actually want. But that could be like maybe 1,000 actors, that could be 100,000 actors. So generally we try to avoid doing something like this. And instead of doing get all actors of class, we create libraries or maps through which we can get these actors. So this is going to take a little bit more memory from from your RAM, but in the long run, it is going to be much better for you because it is not going to cause stalls in any specific form or shape. So when you're doing queries of big groups, generally it's a good idea to have them grouped somewhere where you can access them when you need to. That's why we use maps. Maps are like arrays, but instead of arrays, it's a two-dimensional array, kind of, but not really. It's a key value pair where you can find something by telling them a name of it, and it can return you an object or whatever data type that you need. Spawning and destroying, again, is one of the very expensive process, kind of, depending on the actor that is coming in as well. So we try to find ways around of how to not spawn and destroy when we need to do so. The example I gave for something like bullet hell, where you have thousands of bullets spawning in, we utilize a pooling system where we spawn a massive number of bullets at one time, displace them somewhere so nobody can see it, and when we are shooting, we just bring them back to the scene and let the execution run for the shot. And then when the hit happens or destruction happens, instead of removing it out of memory, we just displace it back. So it's just a queue that gets running, and it saves you. So on load time, you did your spawning, on end time, you did your destruction, and in between, you're just using that same pool of object. A single character, multiple character, or whatever, they can all use from the same pool or multiple pools, however you feel like. So if you're making something like this, generally 1,000 bullets are really expensive to spawn and destroy. You're going to see a lot of spikes, but with something like this, you're just translating them mostly. So it's not a big problem. It is going to save you a lot of memory budget as well. Then one of the biggest culprits and the biggest problems that happens within Unreal Engine is, or I'm pretty sure it happens in Unity as well, is the utilization of the ticks and timers, or overutilization of that. Not everything requires to be on a tick. A lot of engines allow you to have event-based triggers. Unreal Engine is pretty big on that. So if you have logic on tick, you need to rethink to not call it every frame. If I ever see this with anyone, just to let you know, we're going to have a one-on-one, and I'm going to ask what's like if everything is okay in your life. You know, this is torture. So we already know something's wrong. Right. Next, fixes for memory problems. Really important tool. With Unreal Engine, you cannot live without them. You need to learn about delegates, or what's called event dispatchers. This is a signaling mechanism that exists where we don't wait on something for a tick, but rather when an event happens, we send a broadcast or a signal to any actor that wants to be notified when a certain event happens. So you need to utilize more of these. And they are also going to help you reduce the references. So for those who have studied object-oriented programming, classes and objects, what we do is we have a base class that holds these dispatchers, and they are lightweight. And then we have the child classes, which has the logic, or like the textures and everything, which are very heavy. So when we are calling signals, we basically get the signals from, or dispatchers, or even delegates from the parent class, which are lightweight. So we don't load the whole thing if something happens, or when we don't need the object. The second thing is interfaces. Very important once again. This is the same idea. What we do is we create a class which is just functions. It does not have any functionality. It is just function declaration. And whenever we want to use this function, we inherit from this specific class and implement the functions in those specific classes. And then we can do massive calls without knowing which actor or what implementation needs to be run. But we just do the call, and the class itself handles the functionality of it. So utilizing both of these are very essential when it comes to Unreal Engine, because this is how you're going to be dereferencing and removing things off memory, and not load your whole game into the memory as with one asset. Then the next thing is soft object references. We talked about hard object references. Ramil talked about how it loads everything. So hard object is anything that you directly reference. This can happen through when you create a variable to a variable of a data type, or it could be like when we do something like casting. If you don't know what casting is, it's basically when you get an actor and you're saying that, hey, are you potentially of this different type? That is casting. because we want to access its functionality, and we cannot access its functionality without knowing which group it actually belongs to or which class it belongs to. So we do a cast. So we changed those to soft object. Hard objects, hard references immediately load into memory, even if you are not actually utilizing that object. Whereas soft object only gets loaded into the memory when it is created. So you have more control. On the same topic, there is a thing called primary assets, and it performs in the same way. This is part of your asset manager, and you can choose what to load, when to load, and so on. When we are utilizing load and save and load systems, generally this becomes part of it. With Aeon Must Die, this was one of the massive, we used it massively because when we were creating tooling and so on. So we create different bundles, we get a level, and we create this whole package, which on runtime, because we had like about 20, maybe more levels, and we wanted to only load a singular level, so we would go through primary asset, and everything that was in the level package, we would just load that, and that is it. So it gives you more control. And that is it. Thank you all for listening, and if you have any questions, feel free to ask. Yes?
It's less of a question, more of an acknowledgement that it's nice that all of the good practices that I've learned using Unity are also present here in Unreal.
Yeah, absolutely, because game dev, we transfer a lot of concepts around, and these good practices, like whenever you open a best practices page for Unity and anything else, other than the tool-specific thing, everything is going to be, like, there are going to be similarities into it. These are not like alien. If you worked on any of the engine, you're going to come back to it. So yeah, you're absolutely right on that. Yes? I see.
More general question about the optimization. How often should we check our games? Like every major feature release, every minor feature release, every time we do anything to our game?
Yeah, so the way it happens is one question is more like when you're setting up your architecture, what kind of architecture is going to use. But beyond that, generally, we have what we call release cycles. So in project management, there is the idea that like every 3 months or so is a release cycle. And we're not doing with every feature, but rather we are batching it in a way where we get to evaluate the whole project. And then when we are releasing, we have like, okay, 2.5 months of this happening and 2 weeks of we are going to do optimization, finalization, sending out, and so on. So we don't want to over-optimize. We want to test at the end of every release when you're kind of like doing like this major update where everything is going to check in. Right, I see a hand like right back there, yes.
Yes, I have a question. I know some experience when I'm playing Unreal Engine 5 games like Robocop and the Finals. They have a particular, I have an auto CPU processor, so they have a very particular issue where they take a lot of resources in the beginning, like for example 80% of the CPU, and they'll completely fine after they launch the game, then the CPU is completely fine,
yeah.
max out 50%. But what causes that like very large CPU intensive spike at the launch of the game, and how to avoid that?
Yeah, so that's the same thing that we were talking about, like with primary asset IDs, when we are loading things into the memory and so on. So the way we want to structure the game is that once you start interacting with the game, you do not have any interfaces, right? This happens in game design as well, where we kind of go like, hey, what are the essential points where we can interrupt the player, and what are the points we don't want to interrupt the player? So loading screens and launches are the best places where we can interrupt the player. So what we do is we transfer the heavy loading and so on to be there. Well, I talked about the topic about spawning and destroying are very expensive, right? So a lot of spikes that happen generally is that when the level is loading on the loading screen or the start of the game, they are spawning quite a lot of things. And that's what like the spikes happen. Once that happens, once you're done with it, once your game launches and you're playing it, the processing that is being used is for rendering and drawing, and the logic that is in there, which includes things like shooting someone or a mission going forward or loading and saving. So that's why like a lot of spikes happen on the loading or the startups and not while being within the game itself. And that's generally a good thing for us. Yes?
Games are often built on templates, but it can be built from scratch, right?
Yeah, you have templates which allows you to have like a bit of like pre-given code, which is like first person and third person, but you can start a blank project.
So my question is, if templates can be a problem, obstacle for future optimization in some way?
Could you repeat that?
And my question, if you have a choice from scratch or template, if templates can become problem, obstacles for future optimization.
Templates are not that heavy. So the templates that you are going to see, they are something that they just give you a base code more or less, but they do not have enough code that are going to ever cause you a problem in terms of optimization itself. The optimization problem more comes in from the project settings and everything that is active, like Lumen and Night are active by default. There are a lot of post-processing effects that are already activated by default, right? These includes motion blur, for example, or there's a whole set of features. Exposure, for example, these things are automatically activated. So whatever template you might pick, these things are going to be there. And you need to kind of go through them and turn them off. You can also, like when you're starting up your project, whether it is template or not, you can select the project to be started with ray tracing. So if you do that, you're going to already have an issue, kind of, So you don't want to do that. I hope that answers your question.
More or less.
All right. Anyone else? Yes.
Is it possible scenario when you are actually just switching game engine as optimization choice? Is it possible?
You mean going from like Unreal to Unity or Unity to Unreal?
Yeah, to go to Unity just because of optimization purposes.
Yeah, I mean, it depends on what state your project is in. So if you're in the concept stage, I think it is, or pre-production even, right? I think it's a really perfect thought process to go like, hey, do I actually want to stick with it? Or do I want to move? Because it also depends on the skill your team has, whether you or your team as well. I have been working with Unreal Engine for like quite a long time. Unless I have a very specific reason to move out of it, I don't need to because I can optimize Unreal Engine to the place I want to do so. But I think Godot and Unity are very fair engines where you can go and you can start out and you can play with them without worrying too much about optimization at the beginning. So it's absolutely, yeah, right. So I think, am I up on time? I think I have, if there is any question, cool. Otherwise, I think we're going to end it. Yes.
I had a question about when you had the CPU, the Unreal Insights. Is that if I have I'm doing my project, my I don't know, a little platformer, and
yeah,
of course I wouldn't have this much, but let's say is this some kind of indicative of good health, or like,
kind of? I mean. Yeah.
So is it bad if like one spike is like very, very...
No. So the depth is irrelevant to you.
Okay.
Yeah. The depth is not the problem. The thing that you care about is there is a value that is written on the biggest frame, which is going to say 33.33, or it's going to say 16.6, or it's going to be lower or higher. That is what you care about.
Okay. Just the value. Okay.
So then after that you go like, okay, which one is taking like so much more time, and then you try to fix that. Yes.
Is there something useful for so-called technical artists in Unreal Engine? Should we also teach them just to use it or something?
Useful how?
For technical artists, is there any reason to teach them also engine to some extent?
Yeah, I mean, part of technical artist's job is to bring things into the engine nowadays, right? And that's where the value of technical artists have grown quite a lot as well, because not only are they learning the external tool, but they're also learning more of the engine as well. So tech artists are going to interact with both of them. And if they don't know the engine, they're going to have difficult time. And I've seen that with certain technical artists, but eventually they end up learning as well. And beyond that, there are certain optimization view modes that they get to learn and play with as well, which like enables them to kind of evaluate everything better. Right, is that all? All right, thank you everyone for listening, and I'll catch you all around. Thank you.